Welcome to Study Loop.
So we can say for part A, before part A, we should first convert to SI units. So we have omega equaling 2,000 revolutions per minute, 2 pi radians for every revolution, and then we'll multiply it by 1 minute for every 60 seconds. This is giving us 209 radians per second. And we can say that we're going to also convert the plane speed. So v is going to be equal to 400, say v, the plane will equal 480 kilometers per hour. And for every 1 meter per second, there are 3.6 kilometers per hour. And this is giving us 133 meters per second. So if we wanted to find the speed of the tip as seen by the pilot, we can say velocity of the tip essentially would be equal to omega times r. So this would be equal to 209 radians per second multiplied by the radius of the tip, 1.5 meters, and this would be equal to 314 meters per second. So at this point, we can then say that the velocity, this would be your answer for part A, by the way, velocity of the tip as seen by the pilot. And then we know that the speed of for part B, the speed of the plane as seen by an observer on the ground. So we can say speed of plane as seen by an observer on the ground would be equal to the net velocity. So we can say that the magnitude of the net velocity would be equal to the square root of the sum of the squares. So what I mean by that is the square root of v sub p squared plus v sub t squared. We can solve and say this is going to be 133 meters per second squared plus 314 meters per second quantity squared. We find the magnitude of the net velocity to be approximately 3.4 times 10 to the second meters per second. This would be your answer for part B. That is the end of the solution. Thank you for watching.